Through this video, we will learn how to solve a pair of linear equations in two variables using substitution method. The first and foremost thing in this particular method is to observe both the equations and decide which one is easier to manipulate and express a variable in terms of the other. So let's first and foremost mark the two equations as equation number 1 and equation number 2. From the given pair of equations, it's quite easy to figure out that equation 1 is easier to manipulate here. So let's manipulate equation 1 and express one variable in terms of the other. Here the two variables are s and t, and we can transpose t to the other side in order to express s in terms of t. So on taking t to the other side, we'll get s equals to 3 plus t. We have manipulated equation 1, which was s minus t equals to 3, and we established s in terms of t as s equals to 3 plus t by transposing t to the other side. Now let's mark this as equation 3. So now the next step or the next rule while solving a pair of linear equations in two variables using substitution method is to replace the value that has been expressed in terms of the other variable in the other equation. So the other equation is equation number 2. So now we will put s equals to 3 plus t in equation 2. So we had manipulated equation 1 and established s in terms of t, and that particular value we are putting in the other given equation, which is equation number 2. Now in place of s, we will write 3 plus t by 3 plus rest of the equation we will write as it is. Now the LCM of 3 and 2 will be 6. So we'll solve the equations normally the way we used to solve other mathematical equations. So 3 2s will be 6. So this particular numerator will be multiplied by 2. 2 3s are 6. So this will be multiplied by 3. 3 into t's will give us 3t equals to 6. Now simply multiply. 2 3s will give us 6. 2 plus 2 into t's will be 2t plus 3t equals to this 6 can be transposed to the other side and will get multiplied with the 6 that was already there on the right hand side. 6, these two are like terms. 2t plus 3t will give us 5t equals to 6. 6 will be 36. Now we will take 6 to the other side, so we'll get 36 minus 6. So 5t equals to 30. So t equals to 30 by 5. 5 1s are 5, 5 6 are 30. So the value of t is 6. So we got the value of t as 6. Now simply we need to replace this particular value in equation 3, which we had derived after manipulating one of the given equations, and then we'll get the value of s as well. So now let's do that. Put t equals to 6 in equation 3. In fact, we could have used any of the given equations as well, but using equation 3 will be much more easier. So s equals to equation 3 is 3 plus t. So 3 plus in place of t we'll write 6. So s equals to 9. So we got the value of s as well. So this is how the substitution method works. Now let's solve one more question using the same method. In this particular question, the given pair of equations are 0.2x plus 0.3y equals to 1.3, and the second equation is 0.4x plus 0.5y equals to 2.3. Since we have equal number of digits after decimal places in all of the coefficients as well as the constants, so we can easily remove the decimal places. So we can simply write 2x plus 3y equals to 13 and 4x plus 5y equals to 23. We could do this because there were equal number of digits after decimal places. Now let's mark them as equation number 1 and equation number 2. Now, as per the rule, we need to manipulate one of the two equations in order to express one variable in terms of the other. So let's manipulate equation 2 this time around, as manipulation is totally up to us. We can manipulate equation 1 or 2. That's totally up to us. Sometimes we need to check the equations and figure out which manipulation would be easier for us, since both the equations looks quite the same this time around. So that's why we have went ahead with equation number 2, which is 4x plus 5y equals to 23. So we will shift 5y to the other side, and remember we could have shifted 4x also to the other side for that matter. Now finally we'll take x to the other side. X equals to 23 minus 5y by 4. So after manipulating equation 2, we have successfully expressed x in terms of y. That is, one variable is now expressed in terms of the other variable. Since we have manipulated equation number 2, this value should be replaced in equation number 1. So put x equals to 23 minus 5y by 4 in equation number 1. Equation 1 is 2x. So 2 in place of x, we will write 23 minus 5y by 4. Rest of the equation will come as it is, plus 3y equals to 13. This 2 can be cancelled. 2 1s are 2, 2 2s are 4. So we are left with 23 minus 5y by 2 plus 3y. 3y does not have a denominator, so let's write 1 as its denominator equals to 13. The LCM of 2 and 1 is 2. So 23 minus 5y plus 2 3 is 6y. Now we can take this 2 to the other side. 23 minus 5y plus 6y equals to 13 into 2. 23 plus minus minus, 6 is the bigger number here. So 6y minus 5y will give us plus y equals to 13 2 will give us 26. So y equals to 26 minus 23. This will give us the value of y as 3. So we have got the value of y as 3. Now we will use the value of y equals to 3 in equation number 3 only, which we have derived after manipulating equation 2. So we'll write next, put y equals to 3 in equation number 3. So equation 3 is x equals to 23 minus 5 into, in place of y we will use 3 divided by 4. So we'll get x equals to 23 minus 5 3s are 15 by 4. So x equals to 23 minus 15 will be 8 by 4. So 4 1s are 4, 4 2s are 8. So we got the value of x as 2. So we have also solved this particular equation using substitution method. Now let's solve one more question using the same method. The two equations this time around are root 2x plus root 3y equals to 0 and root 3x minus root 8y equals to 0. Let's first mark the two equations as equation number 1 and equation number 2. Now to start with, we can decide which equation we want to manipulate. This time around as well, we can see that both the equations are quite the same. So let's manipulate equation 2. Remember, you could have manipulated equation 1 as well. So equation 2 is root 3x minus root 8y equals to 0. So root 3x equals to, taking minus root 8y to the other side, we will get plus root 8y. And since we didn't have any other constant, so this will be our equation after transformation. So finally, we'll take root 3 to the other side, we'll get x equals to root 8 by root 3y. So this we will mark as equation number 3. We have expressed x in terms of y by manipulating the second equation. Since the second equation has been manipulated, we will put the value of x in the other equation, that is equation number 1. Had we manipulated equation 1, we would have used that value in the second equation. So equation number 1, root 2, in place of x we will write root 8 by root 3 y plus root 3y equals to 0. So now multiplying root 2 into root 8, 2 8s will be 16y by root 3 plus root 3y equals to 0. Now root 3 can be taken LCM here, as the other thing does not have any denominator, so we'll assign 1 as the denominator. So root 3 being the LCM, we'll get root 16y plus root 3 into root 3 will give us root 9y. 3 3s will be 9 equals to 0. Now root 16 means 4, as 4 4s is 16, so we can write 4y plus root 9 can be expressed as 3, so 3y equals to 0 into root 3. Remember, root 16 is 4 into 4, that's why 1 4 has been taken out, and similarly root 9 is 3 into 3 inside square root. So from a pair of 3 inside square root, we have taken 1 3 out. So next we'll have 4y plus 3y giving us 7y equals to 0 into root 3 will be 0. So y equals to finally 0 by 7. So we'll get y equals to 0. So now we'll simply put this value in equation 3 in order to get the value of the other variable. Put y equals to 0 in equation 3. So this is our equation 3. X equals to root 8 by root 3 y. So x equals to root 8 by root 3 into 0 will give us x equals to 0 as well. So in this particular question we got the value of both the variables x as well as y as 0.